Sai Ram. Dear learners, welcome to Shri Sathya Sai Lok Seva Gurukulam online classes. We are doing Senior Secondary Mathematics, Chapter Permutations and Combinations. This is Part 8. In Part 7, we did problems based on permutations having certain conditions. Now let us see what is combination. We have used the word permutations and combinations. Let us try to see the difference between these two words, permutations and combinations. In permutation, it was arrangement of objects. For example, if we have two objects A and B, they can be arranged in two ways. One is AB and other is BA. That means the order in which they are placed is important when we are talking of permutation. Now what about combination? We have two things, A and B. We have to choose two. So we will be taking it AB. Now whether we write it AB or BA, it will mean the same thing. Now suppose we have three objects A, B and C. What are the different ways of arranging these three objects A, B and C? ABC is one way. Then ACB is another way. Then let's start with B. AC, BCA. Then we can start with C, AB and CBA. So these are the 6 permutations. Now what about combination? There are three objects A, B and C and we have to choose all three of them. So what will we do? We'll take A, B and C. Now whether we write ABC or we write down ACB or we write down CAB, in combination the order will not matter. Permutation we were representing by P. If I am writing 3P2, what does this mean? For example, we had these three objects A, B and C. What is the permutation of choosing two objects out of three? At a time we can choose only two objects. That means out of A, B and C we can either take AB or we can take AC or we can take BC. So if we take only two objects at a time, so how do we represent it? We represent it as 3P2. Total were three objects and out of which we are choosing at a time two. So we will be representing it by 3P2. And what was the formula for 3P2? It is factorial 3 upon factorial 3 minus 2. So what will come? Factorial 3 upon factorial 1. And this is 3 into 2 into 1. That is 6. So if we had to choose two at a time out of A, B and C, what would these 6 arrangements be? AB, BA, then AC, CA, then BC and CB. So these are the 6 arrangements. When we are talking of combination, it is represented by C. Let me just show it to you. How can we choose 2 objects out of 3? And how are we going to represent it? So it will be represented 3C2. We are choosing 2 objects out of 3, and what are the various ways of doing it? Now here you see A, B and C, 3 are there. We can choose only 2. So what can we choose? We can choose AB. Now whether we write AB or BA, it doesn't make a difference. It would be same. We are just choosing 2 objects. Then we can choose AC, A and C, and then we can choose B and C. So out of 3 objects, we are choosing 2 at a time, and there are 3 ways in which we can do it. As far as the arrangement was there was 6 ways of arranging 2 objects chosen out of 3. So this is represented by 3C2, where we are choosing 2 objects out of 3 objects, and the formula is factorial 3 upon factorial 2 into factorial 3 minus 2. I'll discuss this formula in detail. Now let's see what do we get here. So it is 3 into 2 into 1, and here it is 2 into 1 into 1. So here if you see, you get 3 answer, and we have said that there are 3 ways of choosing 2 objects out of 3. So one difference is that we represent permutation by P and combination by C, capital C. Arrangement of objects in a particular order is called permutation. Combination refers to choosing the objects, and here the sequence does not matter. If I write down NCR, that means out of n objects, we are choosing R objects, and R will be less than n, because we have to choose out of the bigger lot. So n will be more and R will be less. The formula is factorial n upon factorial R, and in the denominator only it will be factorial n minus R. This can also be written like this. If you remember, what was NPR? NPR was factorial n upon factorial n minus R. So, can I write it like this? I am separating it, and instead of factorial n upon factorial n minus R, we can write down NPR divided by factorial R. This is also the formula for combination. If it is 5C2, one way is you can write down 5P2 upon factorial 2. Now what is 5P2? 5P2 is factorial 5 upon factorial 5 minus 2. Let's solve it. Factorial 5 will be written as factorial, it will be written as 5 into 4 into factorial 3. And 5 minus 3 is factorial 3, and 2 can be written as 2 into 1. It comes 20 upon 2, which is 10. Or you can do directly also factorial 5 upon factorial 2 into factorial 5 minus 2. Use the method with which you are comfortable. Now factorial 5 can be written as 5 into 4 into factorial 3 divided by 2 into 1 into factorial 3. This gets cancelled. It is 10. Now we'll take up questions to understand the concept better. And our first question is, evaluate 13C3. So let's use the formula. It will be factorial 13 upon factorial 3 and then factorial 13 minus 3. We are using the formula for NCR. Now this is factorial 13 upon factorial 3 into factorial 10. Now in the denominator we have factorial 10. So we will write down 13 into 12 into 11 and factorial 10. I hope it is clear. Why are we writing factorial 10? Because we want to cancel these terms. And factorial 3 can be written as 3 into 2 into 1. And factorial 10 will be copied as it is. We could have written factorial 13 as 13 into 12 into 11 into 10 into 9 into 8 and so on up to 1. And same way in the denominator we could have written factorial 10 as 10 into 9 into 8 into 7 so on up to 1. So there is no point writing that because factorial 10 in numerator and denominator can be cancelled. So we cancel factorial 10. So here we have cancelled these and let us look at this. 3 ones are 3 and 3 fours are 12. 2 ones are 2 twos are 4. So your answer is 13 into 2, which is 26. So value of 13C3 is 28.6. Now let us look at the second part. Second part is 9C5. So what will we write? Factorial 9 upon factorial 5 and factorial 9 minus 5. So this is factorial 9 upon factorial 5 and 9 minus 5 is 4. So let us write factorial 9 as 9 into 8 into 7 into 6 into factorial 5 upon factorial 5, and 4 factorial can be written as 4 into 3 into 2 into 1. Just see what can you cancel. We can cancel factorial 5 and then 4 twos are 8, so 8 gets cancelled. Here we have 3, so 3 ones are 3 and it is 3 twos are 6. So let's see what is our answer. 9 sevens are 63. 63 multiplied by 2 is 126. I hope it is clear. Same way we can do third part, which is 8C2 plus 8C3. Solve it separately. Factorial 8 upon factorial 2 into factorial 8 minus 2 plus factorial 8 upon factorial 3 into 8 minus 3. Solve it. It is factorial 2 into factorial 6, and second term is factorial. In the denominator we have factorial 3 into factorial 5. So try to solve this. I'm trying. Let me write it. 8 into 7 factorial 6 and factorial 6 will get cancelled. And here we have got 2. Same way 8 into 7 into 6 into factorial 5, and factorial 3 is 3 2s are 6, and factorial 5 is written like this. Now see what do we get once we simplify it. Factorial 6 gets cancelled. So this will be 28 plus, and here we cancel this, 56. So we have got the answer 84. Let's look at the fourth part. In fourth part, it is 9C3 divided by 6C3. You can simplify. Factorial 9 upon factorial 3 into factorial 9 minus 3 divided by factorial 6 upon factorial 3 into 6 minus 3. So 9, factorial 9 can be written as 9 into 8 into 7 into factorial 6. Factorial 3 is 3 into 2, and here we have got factorial 6. Same way, factorial 6 is written as 654 factorial 3, and here it will be 3 into 2 into factorial 3. Cancel whatever is getting cancelled. 3 2s are 6, and here it is 3 1s are 3 and 3 3s are 9 and 2 4s are 8. So 84 divided by 20. And 84 divided by 20, the answer would be 4.2. So in this way, we can solve such questions. This particular question I want you to do yourself. I'll just rewrite the question as it is not properly written here. So you have to verify each of these statements. So please find 5C2 and 5C3 and see whether these two are equal or not. Then you will find 4C3 multiplied by 3C2 and check whether it is coming equal to 12C6 or not. In third part, it is 4C2 plus 4C3 and this should come equal to 8C5. Solve left hand side separately and right hand side separately and see whether the given statements are true or not. Fourth part is 10C2 plus 10C3. You have to check whether this is equal to 11C3. Now we will take up some statement sums. Find the number of subsets of the set 1, 3, 5, 7, 9, 11, 13 up to 23, each having 3 elements. First find total number of elements in the set. It is all odd number from 1 to 23. So count the odd numbers from 1 to 23. They are 12 in number. So out of these 12 numbers, we have to choose 3 at a time. So we have to find the number of subsets of this given set, each having 3 elements. So required number of subsets is equal to 12C3. Out of 12 elements, you have to choose 3 at a time. So how many subsets will be formed? So let's solve it. It is factorial 12 factorial divided by factorial 3, and it is 12 minus 3. Solve it. It is 12 into 11 into 10 into factorial 9. And factorial 3 is 6, 3 into 2. And factorial 9 is written as it is. This gets cancelled. 6 2s are 12. And 2 into 11 will be 22. Multiplied by 10 will give us 220. So 220 subsets can be formed from the given set which has got 12 elements. And in each of these subsets, we are having 3 elements. Let us look at the next problem. Now this is quite simple application of combinations. There are 14 points lying on a circle. So circle is there and 14 points are there. Anywhere on this circle, 14 points are there. And they've asked us how many pentagons can be formed using these points. So you should first know what is a pentagon. Pentagon is a closed figure which has 5 sides. Let me draw a pentagon. It has got 5 sides. 1, 2, 3, 4, 5. And how many vertices it has? 1, 2, 3, 4 and 5. So that means 5 points will join to form a pentagon. And when we have got all the points on a circle, so these points are not lying on a straight line. Because we cannot join points, 5 points on a straight line. We will not get a closed figure in that case. So required number of pentagons is equal to 14C5. We have to take 5 points at a time. Now solve this. It is factorial 14 upon factorial 5 into factorial 14 minus 5. Let's see what answer do we get. This is 9 here. So 14 into 13 into 12 into 11 into 10 into factorial 9. And this is 5 into 4 into 3 into 2 into 1 factorial 9. And cancel it to get your answer. Just see what answer do you get. Factorial 9 we will cancel as it is. We'll cancel factorial 9 like this. Then 5 2s are 10, so 10 will get cancelled. 4 3s are 12, so 12 gets cancelled. So you are just left with 14 into 13 into 11. Multiply these and see what answer are you getting. 14 into 13 into 11. We will get 2002. Next, let us look at this question. There is a fruit basket in which there are 5 apples, 7 plums and 11 oranges. And we have to pick 3 fruits of each type. How many choices can we have? Now it is quite simple. Very clearly said that we have to choose, we have to pick 3 fruits of each type. So out of 5 apples, how many we have to pick? Out of 5 apples, we have to pick 3. Out of 7 plums, how many do we have to pick? We have to pick 3 plums out of 7. And they can be any. Out of 11 oranges, we have to pick 3 oranges. So 11C3. So individually we have found for apples, plums and oranges. So total number of ways will be, multiply these. Here. So 3 and factorial 3 and factorial 3, they both get cancelled. So we'll mark them like this. And here we are left with factorial 2 is just 2. So cancel it, 2 2s are 4. We are left with 10 multiplied by, this gets cancelled. So it will be 35. And we are cancelling 3 3s are 9 and 2 5s are 10. So we are having 11 into 15. Multiply all this and see what do you get. We will be getting 57,750. 57,750. Let's take up another interesting question. And you can see, children, here how easy the solutions are when we are using combinations. A question paper consists of 12 questions divided into 2 parts, part A and B, containing 5 and 7 questions respectively. That means part A has got 5 questions and part B has got 7 questions. A student is required to attempt 6 questions in all, selecting at least 2 from each part. In how many ways can a student select the questions? Now this is something which you frequently come across when you are appearing for exams. So in the question paper there are 2 parts, part A and part B. And it is from part A. In part A there are 5 questions and you have to select at least 2 from there. And in part B there are 7 questions and again you have to select at least 2 from there. So just see, let's see, from part A you have selected 2 questions out of 5. In total, how many questions do you have to attempt? 6. Because total questions are 12 and you have to attempt 6 questions. So if from part A you have done 2 questions, then how many questions do you have to do from part B? 4. Then only it comes to 6, 2 and 4. This is option 1, that from part A you selected 2 questions and you did those questions, and from part B therefore you will have to do 4 questions, so that the total number of questions attempted by you is 6. Now if you select 3 questions from part A, there are 5 questions in part A. You have selected 3 questions from there. So how many questions do you have to do from part B? 3, because total questions that you have to do is 6. And option 3, from part A you do 4 questions. Out of 5 questions, you know 4 questions thoroughly, so you do 4 questions from there. Now how many questions will you attempt from part B? You will attempt 2 questions from part B, so that your sum is 6. 4 plus 2 is 6, 2 plus 4 is 6, 3 plus 3 is 6. Can you do this? Attempt 5 questions from part A and 1 question from part B? Can you do this? Or vice versa? No, you cannot do this, because you have to select at least 2 from each part. We cannot have 5 from part A and 1 from part B. We cannot do that. So these will make this table. Now things will be easy. Let's see. We'll write the required number of ways is equal to. Now option 1. You have selected 2 questions from out of 5 questions. So we will write down 5C2. You have done 2 questions out of 5. And from part B there are total 7 questions. Out of those 7 questions you have attempted 4. Now see, total questions 5 plus 7, 12 questions were there, and you have done 2 plus 4, that is 6 questions. Plus, now look at the second option, 3 from each. So part A you have chosen, out of 5 you have chosen 3, and from part B also same way, option number 3, out of 5 you have chosen 4, and out of 7 you have to choose 2. Solve it and see what answer do you get. 5C2, it is factorial 5 upon factorial 2 into factorial 5 minus 2, multiplied by factorial 7. 7C4 is factorial 7 upon factorial 4 into factorial 7 minus 4. Then second term we have 5C3, it will be factorial 5 upon factorial 3 into factorial 5 minus 3. Then 7C3, factorial 7 upon factorial 3 into factorial 7 minus 3. Then 5C4 is factorial 5 upon factorial 4 into factorial 5 minus 4. 7C2 will be factorial 7 upon factorial 2 into factorial 7 minus 2. Please solve it and see what is the answer that we are getting. Factorial 5 upon factorial 2 into factorial 3 multiplied by factorial 7 upon factorial 4 into factorial 3 plus factorial 5 upon factorial 3 into factorial 2, factorial 7 upon factorial 3 into factorial 4. Third term is factorial 5 upon factorial 4 into factorial 1 and towards the end we have factorial 7 upon factorial 2 into factorial 5. Now you should be solving this yourself and tell me what will you get. Here we'll be getting 10 because 5 into 4, factorial 3 will get cancelled. 5 into 4 is 20, 20 divided by 2 is 10. Same way here, 7 into 6 into 5 divided by 6. So we get 35. Again, factorial 5 upon factorial 3 into factorial 2 is 10. And this term will be 35 again. Here we have factorial 5 upon factorial 4, which will be 5. And factorial 7 upon factorial 2 into factorial 5. It will be written as 7 into 6 into factorial 5. 7 6 are 30. 30 divided by 2 is 7 6 are 42. 42 divided by 2 is 21. So find the answer. 350 plus 350 plus 105. So we will get 805. So how many ways can a student select the questions? There are 805 ways of selecting the question. Let's move on to the next question. Again, it is similar to the one which we have done just now. Out of 5 men and 3 women, a committee of 3 persons is to be formed. There are 5 men and 3 women. And the committee has to have only 3 persons or 3 members. In how many ways can it be formed selecting exactly 1 woman? So, if the number of women is 1, how many men can be selected? Committee has to have only 3 members. So, exactly 1 woman is there. So, how many men can be there? 2 men can be there. Then only we get 3. 1 plus 2 is 3. So this is the first thing that we have to see. So let me write the required number of ways. You have to select 1 woman. Out of how many? Total how many women were there? There were 3 women. Out of 3 women, you have to select only 1 woman. So we will write down 3C1. And then multiplied by, we are using the principle of counting. Multiplied by, the committee will have now 2 men. Now 2 men out of how many men? Out of 5 men. So out of 5, we have to choose 2 men. So please solve this and see what do you get here. I hope it is clear how we are doing it. Since only 1 woman is there, so that means there are 2 men in the committee. So 1 woman can be selected in 3C1 ways and 2 men out of 5 men can be selected in 5C2 ways. So let's solve. Factorial 3 upon factorial 1 into 3 minus 1. And here it will be factorial 5 upon factorial 2 into 5 minus 2. Solve it. And just check what is your answer. If you look at it, factorial 3 upon factorial 2 will be 3. And factorial 5 can be written as 5 into 4 into factorial 3. Factorial 3 will get cancelled in the numerator and denominator. So we are having 20 in the numerator and 2 in the denominator. 20 divided by 2 is 10. So answer is, in 30 ways we can select exactly 1 woman and 2 men to form a committee. Now let us look at the second part of this question. In the second part of the question, at least 1 woman is there. At least 1 woman. That means there can be more than 1. So we'll write it this way. First one is the same as it was earlier, only 1 woman. So 3C1 into 5C2. If 1 woman we have chosen, so 2 men will be there. Now what could be the second option? If we choose 2 women, if we choose 2 women, then how many men can be chosen? Only 1, because we have chosen 2 women, so only 1 man, and out of 5 we have to choose 1 man. Plus, can we have the committee having all the females? Yes. They have said at least 1 woman. They have not said that all men or even 1 man is required. It says at least 1 woman. So that means the committee can have all women also. So out of 3 women, all 3 have been selected. And we don't need men because the committee has already been formed. And you can cross check it also. Just see the what is written at the top. It is 3 plus 5. 3 plus 5 is 8. In second term also 3 plus 5 is 8. In third term also 3 plus 5 is 8. That means there are total 8 people. 5 men and 3 women. And now look at what is written towards the lower side. 1 plus 2 is 3. Then second term 2 plus 1 is 3. 3-member committee. Third term 3 plus 0 is 3. So solve it now and see what is your answer. So it will be written as factorial 3 divided by factorial 1 and it will be 3 minus 1. Factorial 5, factorial 2 and factorial 5 minus 2 plus factorial 3, factorial 2, factorial 3 minus 2. Factorial 5 upon factorial 1 into 5 minus 1. And here it will be factorial 3 upon factorial 3 into factorial 3 minus 3. And 3 minus 3 is 0. What is factorial 0? What is the value of factorial 0? Factorial 0 is 1. This you have already studied. And here it is factorial 5 upon factorial 0. And here it is 5 minus 0. Please solve it and see what is the answer. Here it will come 3 into 10. Second term will be 3 into 5. And third term will be 1. Solve it. It is 30 plus 15 plus 1, which is 46. So there are 46 ways in which we can have the committee of 3 people where at least 1 woman is there. In 46 ways we can form the committee. Let's move on to the next question. Again, question number 7 is similar to the ones we have done earlier. and we'll try to do it directly now. A cricket team consists of 17 players, and these 17 players includes 2 wicket keepers and 4 bowlers. But we have to form a team of 11. So in how many ways can a playing 11 be selected? If we have to select 1 wicket keeper and at least 3 bowlers. So let's see directly. Required number of ways. Required number of ways. We have to take 1 wicket keeper. Now 1 wicket keeper out of how many? Out of 2. 2C1. So 1 wicket keeper we have chosen. Then they said at least 3 bowlers. So let's first choose 3 bowlers. Now 3 bowlers out of how many? 4 bowlers are there. So 4C3. Now how many more players do we have to choose? We have chosen 1 wicket keeper and we have chosen 3 bowlers. So 4 people we have selected. Total players need to be 11. So how many more have to be selected? We have to select 7 more, and out of how many do we have to select? We have to select 7 more, and out of how many? 2 wicket keepers, keep them aside. 4 bowlers, keep them aside. 6 people aside out of 17. So how many are left? 11 are left. I'll repeat what I have written here. First we choose 1 wicket keeper out of 2. Then we choose 3 bowlers out of 4. Apart from wicket keepers and bowlers, there are 11 other members. Out of those 11 other members, we have chosen 7. Then only our team consists of 11 people. 1 plus 3 plus 7, 11 people. This is 1 we have written. Now let's look at the second term. In this we are going to have, instead of 3 bowlers, can we have 4 bowlers? Because they said at least 3 bowlers. So that means we can select 4 bowlers also. So let's first choose the wicket keeper. Out of 2 we have to keep only 1 wicket keeper. Out of 4 bowlers we can have all 4 bowlers. Now out of remaining 11, how many do we have to choose? We have already taken 5 people in the team. So how many more can be there in the team? We can have 6 more people in the team, so that we have 11 members. Now please solve it and see what answer do you get here. This I want you to solve yourself. On solving it, you will get 2640 for the first term and 924 second term when it is simplified, and answer is 3564. Let's move on to the last question. Again, this question is similar to what we have done till now. There are 5 vacancies which have to be filled up and 25 applications have come. 25 applications, and out of these 25 applications, 7 scheduled castes, 8 other backward classes, they have applied. So 7 plus 8 is 15, and what is left out of 25? So 10 seats are left, or 10 applications are left. So maybe these are general candidates. Now we only have to fill 5 vacancies. There are 25 applicants but only 5 vacancies. Let's see how to do that. if 2 posts were reserved for scheduled caste and 1 for OBC. So let's take the conditions first. 2 posts were reserved for SC. So these 2 posts have to be filled out of how many candidates? How many applicants? Out of 7? Out of 7, 2 have to be chosen. Out of the 8 OBCs candidates, 1 has to be chosen. Out of 8, 1 has to be chosen. Now we have taken SC, we have taken OBC. Now the remaining ones, that is the general ones, are 10. And now how many posts are left? First you will have to see how many posts have you filled. We have filled 2 posts for SC and 1 post for OBC. 3 posts have been filled. So how many posts are left now? 2 posts only left because total is 5. Now do the sum also of the numbers at the top and at the bottom. Let's do the sum at the top. 7 plus 8 is 15. 15 plus 10 is 25, which is total 25 applicants. Now do the lower one also. 2 plus 1 is 3. 3 plus 2 is 5. So we are looking at 5 vacancies. Please solve it. So factorial 7 upon factorial 2 into factorial 7 minus 2 multiplied by factorial 8 upon factorial 1 into factorial 8 minus 1. Factorial 10 upon factorial 2 into factorial 10 minus 2. Solve it and see what answer do you get. This will come 21. Second term will be 8 and last one is 45. When we multiply all of them, 21 into 8 into 45, we get 7,560. So dear learners, I hope you have understood how to solve these questions. Please practice each of these questions and the solved examples which are given in your books. That's all for today. Thank you so much. Om Shri Sai Ram.